In see about electrical machines lab to Swinburne test experiment number 4. Okay, the Swinburne test is an indirect method for determining the efficiency of DC machines. It works by finding the no load losses experimentally and then estimating additional losses from the rated motor data and generator data. Okay. From this information, the efficiency can be determined at any applied load. Okay, to determine the constant losses and hence to find the efficiency of a given DC machine at any desired load. Why you are mentioning here DC machine? DC machine, a same machine can be operated as a generator and at the same time can be operated as a motor. Okay, so that's why we are calling DC machine. Apparatus required voltmeters 0 to 300 volt and 0 to 30 volt, and ammeter 0 to 5 amps and 0 to 2 amps. Rheostats 0 to 750 ohms, 1.2 amps and 0 to 40 ohms, 8.5 amps. And all the meters are moving coil instruments MC, and tachometer which is used to measure the speed of the machine. Okay, this is the machine of Swinburne test. Okay, so here we add one ammeter to the Z, that is field coil, and here we add one more rheostat, okay, with the value of 8.5 amps, because the current will passes to the armature will be high. That's why we are going for the rheostat which should withstand the particular currents. That's why we are going for 8.5 amps. In the case of field, the current is maximum will be 2 amps because it's a shunt motor. Okay, so the current that rheostat the value will be 1.2 amps, 0 to 750 ohms. Okay, this is to determine the value of RA. RA is nothing but armature resistance. Okay, this is a okay. Connections are made as shown in the circuit diagram, keeping the rheostat R1 in the field circuit of motor in cutout position. Okay, the rheostat R2 in the armature circuit of the motor, it is in cut in position. The supply S switch is closed. The motor is brought to its rated speed by cutting out the rheostat R2 and cutting in the rheostat R1 if necessary. To get the rated speed, we have to vary the rheostats of field as well as armature. Readings of the all meters of speed are noted down. All the rheostats are brought back to home position and switch S1 is opened. The graph efficiency versus load current is plotted shown in the, and determination of armature resistance connections are made, keeping the rheostat in cut-in position. The supply switch S1 is closed. Rheostat is adjusted to any value of current, say 1 amp, and the reading of ammeters and voltmeters are noted down. The supply switch is opened. Let's see the demo of this experiment. Efficiency in the indirect way of machine. The same motor, the same machine acting as a motor as well as generator. Okay. Now we see the connections of this shunt machine. Okay. So from the positive to L, that is L. F is a 3-point starter. For the L, we are giving L from the positive, we are giving the L, and A is the armature terminal of the 3-point starter. That one we should connect the ammeter. It is a 20 amps ammeter, and the connected to A1. Okay, A2 is the other point of meter. Sorry, armature. That return path connected as a return line. Okay, for the field, in this event, we are going to control the field coil resistance. For that, we are adding one external resistance with the field winding. Okay, so LFA from the AF the terminal of to rheostat. The rheostat another item. Okay, here the rheostat value will be in minimum value, rheostat value in minimum, and the rheostat another goes to ammeter. This field coil ammeter is two aspects used for field coil, and the other end of that ammeter goes to F1. Then F2 is the return path that is given to negative of the DC machine. Here we should switch on this switch. It's a main switch. Once you switch on, you can see the voltage present in this DC motor. So, total voltage, total voltage. Then you should switch on the 3-point starter. Slowly. RPM. For the purpose, we have to increase the resistance of the field rheostat. With the corresponding speed. 1396, 1400, 1500. Once it reaches the rated speed corresponding the ammeter readings of field is 0.7 something times. Okay. Likewise, you should measure the armature current corresponding to the calculation. Once we complete the experiment, again we should use home position. We should change. Then switch on the note down that values what we got. Okay, corresponding is a full load, off load, and quarter load, 3/4 of load. We get the different efficiency of the machine as the motor, as the generator, and calculations we should do for both motor as well as generator. This is the efficiency of the motor, generator, and this is the model graph for this experiment, and this is the actual graph what we got for different efficiency for the motor and generator, and thus they determine the constant losses and hence to find the efficiency of a DC machine at any desired load. Okay, these are the some of the important questions which will be asked in your exam, and thank you.